Welcome back, everybody. In our next section, we're going to look at profile number 11, which the important point about this is that it's using BGP for signaling across the provider instead of using PIM, where previously we looked at the PEs and looked at the show IP PIM VRF X neighbors, and we were able to see that we had multi-hop neighbors across the tunnel. Okay, in this example, the underlay signaling is still going to be using PIM, but the overlay signaling is going to be using BGP. Encapsulation is going to be GRE, again, because in iOS XRV we have some issues with the MLDP, as we saw in the one of the previous variations. Okay, so let's go ahead and take a look at the documentation for this. So what are the other steps that are different in profile number 11? Okay, profile number 11 is using GRE for transport, using BGP auto discovery to find the endpoints, but then it's also using BGP for customer multicast signaling. Okay, so MDT auto discovery PIM, same as what we were using before. MDT default, same as what we were using before, but now we have this new command, MDT overlay use BGP. Okay, so let's take a look at our provider edge routers. So provider edge in this case is router 1, router 3, XR1, and XR3. And we want to see, first off, on router 1, what do we have configured for this particular VRF? Okay, so let's look at the show run VRF. Okay, VRF basically same as the example, MDT auto discovery PIM. We have a default tree, and then we're using BGP for the overlay. Okay, this also assumes that we have address family IPv4 MVPN as opposed to MDT enabled. Okay, so under the BGP process, we should be peering with, let's say, show BGP MVPN IPv4 MVPN all summary. Okay, so we are peering MVPN, and notice that we're receiving one route. Now, I want to say this is going to be the route to the iOS box. Hopefully the XR boxes will behave, but like I mentioned, there are some problems with them in the data plane, or in the control plane as well as in the data plane. Okay, so let's try what I had done for my Hail Mary in troubleshooting before, which is commit, replace, confirm, 30 seconds, and let's see if reloading the config on the XR boxes has any effect onto them. Yes. Okay, in the meantime, let's look at the regular iOS devices. Okay, so on router 3, let's show run VRF. Okay, under the VRF, we have multicast distribution tree auto discovery. Default is 232.111, and then we're using BGP for the overlay. Okay, so now let's look at the show BGP IPv4 MVPN all. Okay, so we have some routes advertised by router 1, some routes advertised by router 3. Okay, so now let's see what changes once we actually go to signal across the core. So let's go back to the diagram. And previously, as we had defined on the customer network, in the customer network, router 5 is the rendezvous point, and it's also a bootstrap router. So ideally, what we should see is that the PIM message comes in, we exchange this over the tunnel, and then it pops out on the other side on router 7. So the way to verify this would be to go to router 7 and to look at the show IP PIM RP mapping. Okay, we do know about router 5 as the information source. So it's the bootstrap router, and it is the rendezvous point itself, which means that the tunnel between router 1 and router 3 is working. Okay, so next thing we're going to do is we're going to ping across the tunnel, but we're going to look at what potentially changes inside BGP when we do this. So we're going to show BGP, IPv4, MVPN for all tables. And now we're going to ping across. So we're going to ping from 7 to, let's say, 6. Okay, so on 6, we're going to join a group. And, okay, so on the loopback, we'll say IP IGMP join 226.789. Okay, so some new unique group. And let's go ahead and check this from 7. Okay, so we are able to get transport. And if we look at now in the BGP table, here is the difference. Okay, the register messages basically were replaced by BGP messages. So instead of running PIM across the tunnel, we now have that entry, the S, G entry, 7777, 226.789, and this is now advertised as a BGP update. Now at the other end, it's going to get converted from BGP back into PIM. So from router 5's point of view, when we look at the show IPM route, we should see these as regular sources that are registered as S, G pairs. Okay, now let's look at the transport for this. So the ping is going through. Let's go to our hypervisor. So let's go to viral, and we're going to create a new traffic capture. Okay, let me make sure I'm on the right viral box, which is this one. Okay, so let's say that on router 2, gig 2, and we're going to traffic capture, create. Let's see, our ping should still be going through, which it is. And then let's look at on the capture, what does this look like in the data plane? Okay, so we have our ICMP messages. These are being received on port 37. Okay, so 37, this is the customer to provider link on the bottom right. So they come in as just native ICMP, and then we're putting them inside a GRE tunnel. Okay, the outside destination of the tunnel, this is the MDT default, 232.1.1.1. The inner destination, this is the one that we had joined and we were pinging. So from the data plane, nothing has changed. What's changing here in profile 11 is the overlay signaling. That previously we were using BGP to auto-discover, so we were advertising a route into MDT, or we were advertising a route into MVPN, and we're saying, hey, this is my loopback address, this is the multicast address that I want to use. Okay, so same thing is happening here. So we're advertising to the other neighbors, we want to participate in the tunnel. The difference, though, is that when a join comes in or a register comes in, those are mapping to new types of BGP updates, which means that you would have to troubleshoot potentially multiple protocols. You have PIM on the customer side that is running regular routing inside the VRF, and then you have BGP on the provider side that's doing your VPN version 4, your L2 VPN, but now you're also doing with IPv4 MDT, you're doing this additional, this BGP advertisement.